All right, well, welcome to our workshop today about focusing on Streamlit, which will allow you to create a user interface for your data science projects. So before we get into the actual talk, we're going to start with some installation because it might not be the fastest process. So we are going to assume that you already have Anaconda installed. Thumbs up if you have Anaconda installed already. On your computer. I think most people should. Okay, I think that, okay, all right. Well, if you don't have Anaconda installed, this will be a great time to do that. And you can just do that by visiting their website and downloading for the appropriate platform that you have. But let me go ahead and send you the link to the repository, and then I will share my screen. So that's going to be the link to the repo. And as promised, let's get a little screen share going. All right, and this is the repo here. So as you can see, we have some different files that we don't normally see in the repos that we've done in our previous workshops. So you have this basic analysis notebook, which is going to look super familiar. We're just going to go over that to kind of describe some of the steps that one might do for an analysis. Then we have this module essentially that I've just packaged up some of these functions in here so that they'll be easily accessible. This is what we're going to use, this environment.yaml. This is what we're going to use to create our Anaconda virtual environment. And it'll just basically allow you to create an environment so we all have the same packages on your local computer. I'll get into these in a few minutes. So just FYI, if you fall behind or something happens or things take extremely long, here are the installation steps that we're going to go through in just a moment here. And so you can follow along there. Okay, so we're going to start by just opening the Anaconda prompt. And so you can do that by going to your little magnifying glass. And on OS X, this is accomplished just by opening the terminal if you have Anaconda installed. Otherwise, we're just going to type Anaconda prompt. And so on Windows, this will allow us to have a terminal access using Anaconda. So we're going to type that. Okay, so this is popping up for me. Basically, what we're going to do in this next step is we're just going to clone the repository so we can get access to all of our source code. So right now, I am just going to go into a directory that I prefer, and I'm going to do that using CD. So that just means change directory. And I'm going to go into documents. And you don't have to do this. You can feel free to install or clone this repository where you're familiar with or where you like. So you can CD even further or just leave it where it is. I am doing this. And again, don't worry if you're not able, if you don't have documents for some reason, you can clone it exactly where you are. Let me see. Let me just go ahead and grab the chat just in case. Okay, so now we're going to clone the repository. I think you guys are well acquainted with the steps so far. So basically, you go to the repo that we have. We see this green code button. I'm just going to make this a tad bigger. We see this green code button and we click it. We make sure that we're set to HTTPS. And we click the clipboard to copy to our clipboard. Then we go back to our command prompt, or our Anaconda prompt in particular, and we type Git Clone. And then you may be able to Control V. Can I Control V? Oh, I can Control V. So Control V. On other platforms, that might be Shift Insert. It might be right click with the mouse button, but we're Control V here. And then we just press Enter. All right, so here you can see that we cloned the repository. Now, so it would be helpful for me to dir, but I can't. So there's lots of things here in this directory. This basically shows everything that's in my documents. And here you can see that we have Streamlet intro. So to then gain access to everything that's in that folder, we want to go into that folder. So now we just type CD and we can start typing Streamlet intro. So STREAM. I always like to tab complete. So I just tab that. And now I've got Streamlit intro, and I press enter. And if I ls that, or sorry, not ls on Anaconda. So also if you're on OS X or on Windows or on Mac, you would be typing ls here. Because we're on Windows with the PowerShell, we're typing dir. So it's ls for people that are on Windows, and I would be happy to slow down. Thank you so much for asking about that. Okay, so let's just pause for a moment. If anyone has any questions, let me know, or if you just need to catch up for just a second. Right. So has everyone CD'd into Streamlet intro? So is everyone currently in this directory? Let me pull up my participants list. All right, receiving screen checks. If you need a little bit longer, just go ahead and do a red X, or feel free to unmute and ask a question. All right, this is looking great. Okay, so now we are in Streamlit intro. Again, we can type dir. If we're on Windows, to get our directory contents, again, ls. On Mac, to list the contents that are in that directory. And here you can see everything here is the same as what we have here. So now we know that we're in this folder. Okay. So as we said before, what we're going to do is we're going to try to make an environment. So it's going to install all the packages that we need for this workshop. And so the way that we're going to do that using Anaconda is just like that through Anaconda. And so if you need to see, again, the actual command, it's here. Unfortunately, okay, let me see if I can make that. So it's going to be this, conda if create -f environment.yaml. So that is what you're going to type here. Conda if create -f environment.yaml. And now you can also kind of see why we had to declone this and get it to this directory. So it would know what we were talking about when we said environment.yaml. This basically says, hey, Conda, create this environment using this file called environment.yml. And then you're going to go ahead and click enter there. So you're going to click enter. And that's going to start you down the road of installing your relevant packages. And as your installation completes, like, can you please put that like in the chat so I can be kind of abreast of where everyone is in terms of the installation. So if this asks you any questions, like, would you like to install these packages? Like, click Y and then enter, and that'll say, yeah, Conda, like, please do that. And so you'll be able to move forward. And so I'm not doing this right now because I already have this environment created. So for Windows users, it's possible that you might run into a small error. And let me show you what that looks like, because I've already ran into it. So here you see, okay, let's go back. So here you see that I did the same thing, right? And then I ran my conda if create -f environment.yaml. And this is exactly what you will see as well, even on Mac. So it'll start collecting this metadata. It'll try to solve their environment. That basically says, here, I'm trying to understand all these different packages. Which version should I get? Okay, let's pick. So then after it does that, this is a message that's just for me. You might get it too. I need to update my conda. But then it'll start downloading and extracting your packages thusly. So here you can see we have all the things that we needed to install. Yours might be a little bit longer depending on or shorter, depending what you've already installed in the past. Then you'll see it say preparing transaction, verifying transaction, executing transaction. Okay, then it'll say done. Things will seem fine. Okay, and so after this part completes, that pretty much means that your Anaconda part of your packages are successfully installed. Then it needs to install things specifically through a package manager called pip. And so it tries to do that. Sometimes that might fail. That's okay. As long as our Anaconda environment is already created, we can always install other pip things. Okay. So we get to this done. Things are great for Anaconda. Then I got this particular error again. It was saying, I don't really like what you're doing here with this pip. I don't appreciate you. So I said, okay, that's fine. So I got this huge error. Said failed, hurt my feelings, pip failed. No problem. At that point, since our Anaconda environment has been created, we can still activate it. So then we'll just activate it, and the name of that environment will be called Streamlet Imp. And then we just install the packages that we have. So I do know that this will come a little bit later. This process is not the fastest, so we'll discuss other things in the meantime while things are installing. But do keep in mind, if you run into any of those errors, it's explicitly written here how to do what I just said. So basically, again, if the pip fails, that means you can still activate your Conda environment, and it'll be called Streamlet Imp. And then you'll just install nbdev and Streamlit, and then you should be set. So again, whenever that's working for you, just let me know in the chat. And so we can move on to a little bit more of the Streamlit things. Ooh, exciting. All right. Thanks, Donnie. Thanks for letting me know. That's exciting. It's good to know when things are working. Fantastic. All right. So in the meantime, while things are installing for people, let's talk a little bit more about Streamlit. And if you have any questions about things going awry, you can feel free to put them in the chat and we might be able to help. Otherwise, it could be instructive to maybe just follow along and then maybe email us at the end and follow along until then. And again, we do expect for this process to not take a short period of time, especially in Zoom. This is one of the reasons that I had to install it beforehand, because I can't actually even do anything else while I'm on Zoom. So the fact that this is taking any period of time less than 10 years for you while you're on Zoom is remarkable by my standards. Okay, and do recall that the repo is here under the Streamlit intro. If there's anything that you missed with the installation, please keep in mind you can visit here and follow the instructions. The first step that we did is just to clone the repo. So we cloned this particular repo using this command. Then we CD'd into Streamlit intro because we need to be able to access the environment.yaml file. And once we CD'd into there, then we did conda imp create-f, which is making our long conda install. And again, not immediate, takes time. And so in the meantime, while that's installing, we're just going to talk about other things, let that get done, and then we'll come back to the actual usage of the code. So no worries there. All right, so let's talk about Streamlit in particular. I'm excited to talk about this today. All right, let's see. So here in the repo, we actually have a few resources that we're going to talk about. So let's just start with streamlit.io. So we'll just click there. And so thumbs up if anyone has ever done like development of user interfaces, and I'm going to call them like UIs or GUIs here. So if you hear me talk about that, that's what I'm talking about. Has anyone done any development of GUIs or UIs in the past? You can just give me a thumbs up. All right, I see some. All right. Oh, so some people are pretty fresh on this. All right. My next question was going to be what platform, but it looks like most people, this is going to be your first foray into UIs. So that's pretty exciting, and that's actually good news. So a traditional development of user interfaces can be very complex, and the full featuredness of them makes them more complex to implement. Something that's great, though, is the fact that we have UIs. So we're not always just looking at the Python code. We're not telling people to do like what we're doing right now. So I mean, we're not telling people that want to interact with our website or interact with our data or our models. We're not telling them, hey, if you could go and do this really long download of Anaconda with all these packages, that'd be great. Like, we're not telling them to do that. We're giving them a platform upon which they can click and move things and understand what's going on with our data, with our models, and with our results. So Streamlit is a really great way to get into this directly. It pretty much moves the focus of your work away from the struggle of actually implementing the back end of user interfaces. It allows you to directly interact with the UI elements and focus on your modeling and your results instead. So let's see what that looks like. So here you can see some examples. So this is them just kind of telling you what the basic experience would be like. But some great things about Streamlit are that it's just this. Things can go really, really quickly in terms of development. A lot of it is very fully scripted. This is something that I found to be really, really interesting. This is something also to be careful about. In terms of more robust UIs, it tends to be that people do like to separate the functionality from the actual UI elements, but that's okay. Here, again, the focus is not the development specifically of this really super full featured UI, but to allow people to interact with our models and with our data and results. So the things that you'll see will be very script-like, and this will allow us to develop our app a little bit faster. This is another thing that I really love, which is that there are so many different elements that are available through Streamlit, and that allows us to implement a lot of functionality very, very quickly without having to try to figure out how we ourselves are going to implement this slider or implement this file chooser. So these things are all here. It's just a matter of understanding how to use them. And we'll go over some of these elements today. This is something that is very, very powerful in the fact that it's very straightforward to deploy apps using Streamlit so that anyone can interact with them. So instead of having to host it on your own server, instead of having to do all these back-end server kind of knowledge that you would need to do, you're able to share using Streamlit's service. And so there is kind of a gotcha there in that it is invite only, so you have to request an invite. But there are other ways to deploy your website, which are also, or your app, which are not as difficult as they otherwise could be. Also, Streamlit has a really great user community. So if you have questions about deployment, if you need to do it on your own server, then those resources are really descriptive in how you can do that. They're very step-by-step. So it's not like you have to figure out a lot. Lastly, I would suggest that you take a look at their app gallery, because it gives a really great overview of some of the things that are available through Streamlit. And so actually we can scroll back up to the top and go and actually look at the gallery. So here we can click there. And here we see a number of different apps that have been developed and deployed through Streamlit. So we can see here, let's pick one. Let's see, I found a really cool one yesterday. Ooh, I liked this one a lot. It's called Train Generator. Click this. So now you can see that I'm on the Streamlit app. This is exactly what yours will look like as well. You can see that we have some main type of page where we're able to interact. And this one is specifically about generating code for you to do your training. And so here you're able to pick the different types of tasks you want to do. You're able to implement or pick the different frameworks that you want, and then you're able to get these default kind of templates, and all through Streamlit. So instead of having to do this really complex UI development, we have Streamlit that has made all these types of things available to us. And not only that, it's good looking. So we're not having to decide on the basics of what type of font do I want? What kind of spacing do I want? Which colors do I want to pick? Like, those are things that you can definitely specify, but by default, like, things are already looking good. And so that's something that I'm really just absolutely horrible at. Can never pick colors, fonts, nothing. So I really love that the default behavior of Streamlit is already very, very good. All right. Well, and looking at that, okay. So how are people's installations going? Green check if installed successfully. Red X if still installing. good, looking good. All right, looking good. It's still installing. Strong suggestion to put a red X. Otherwise, we're going to jump right into things. Okay, all right. All right, no problem. There's other things that we can for sure look at in the meantime. All right, that's sounding good. All right, so number 3, documentation. I love documentation, and we're going to be sitting in this documentation at length. So keep it open, keep this page open. We're going to be looking at this a lot. This workshop is really less about, let me teach you how to do every single little thing in this world. It's more like, let's learn how to use this API and use the documentation to be able to generate our own work and our own website, our own app, when the case arises that we need to do that. So we're going to be relying really heavily and leaning really heavily on understanding how to use this API and what's contained in it. Okay, so this is where we get to with docs. First, something I always go to, love getting started. So whenever I jump into something, I start up right with the get started. I think that actually is this. And then you can see the basics of how things are going to look, right? Okay. So let's look at this. So in general, what you're going to do is you're going to make some app as a Python script. This is the kind of information that will be in it. So you'll always need to import Streamlit. And then any other packages that you need. And then right when you decide that you want to run it, you open up a terminal and you just type this command, Streamlit run, and then the name of your script that you have. Okay. All right. There are lots of different ways that you can then interact with your app and build it up. So we saw things that we had before on the gallery. We saw some of the examples. So these are the ways that we implement that. So for example, if we want to add a title, we can do that by using this st.title. We can write things like data frames. We can use these magic commands, which are actually quite interesting. They essentially mean that whenever you want to write something, so writing is a default way that you put anything onto your app to be shown. You can not write st.write, but just kind of print it and it will be shown. You're also able to draw different types of charts and maps. So like line charts specifically through Streamlit, but you also have the functionality of using the specific writing commands. So like a Plotline chart or an Altair chart or different types of charts. Here, they're just telling you a little bit about the widgets that you have available. So like checkboxes, select boxes. You have different types of ways that you can do layouts, show progress bars, and then it tells you a little bit about how you can share your app. Okay, so that's a nice getting started. It gives us a really great overview of what we can expect to see in the API, right? So that's how I usually use the getting started page. They like to tell you about like a grand overview, and then you can kind of see what you can expect when you get into the API. So now we're actually going to mosey on over back to Jupyter Lab. It looks like things are doing, looks like the installs are going pretty well. Where are we? Where are we here? Oh, I can't see it. Yep, there we go. So where did you open Get Started Streamlit? Great, that is a great question. So the way that I opened that is I was in the repo. So what is called Streamlit intro. And I think that's in the chat. And then I just use the resources here. Oh, I spelled that wrong. That's unfortunate. You can go to Streamlit Home, but also the getting started is directly in the docs. You can find all of those things, well, you could straight across here. And here's the getting started page right here. All right, so I think it's a good time to try this on our own. Oh my goodness. So I am going to start, so I'm actually going to open up this API reference because we're going to come back to that. You don't have to open it now, but woo, we are going to be in this today. But otherwise, let's get started in understanding what's going on in our workshop files. Okay, so let's see. All right, so here we were. We installed things, and we're also now in Streamlet Intro. So is everyone in Streamlet Intro? Clear these. All right, things are looking good. People are in Streamlit Intro. So I'm going to open up Jupyter Lab because that's what I always open up. If you're dying to open up Jupyter Notebooks, you can do that too. But I just type Jupyter Lab.
And quick question, should we already be in the environment?
And that is a really great point because I certainly did not just do that. So actually, I'm going to take this. We're going to open it up. I'm going to shut that down and try again. Round 2. All right. So base says base, bad signal. We don't want to be in base. We want to be in the environment that we just created. Thank you for that, Jesse. So we're going to type conda activate. And we're going to activate our environment that we want it to be in. So it's called Streamlet Imp. And yes, you should follow. So as much as you are able, you should be actively coding along with me.
And reminder, of course, we'll have the recording up as well. So if at any point you're not able to follow along, then you can watch the recording a little bit later as well. So, but do feel free to, raise your hand or put up a red X. But you'll be able to catch it on the recording as well.
All right, so now we're going to activate this environment. And here you can see that now we're in Streamlit Imp, and now we're going to open Jupyter Lab. All right, so we are not running quickly. I told you guys, I told you Zoom and anything on this computer. It's a nightmare. It's okay, but we're going to make it though. That's what's important. All right, so now we've opened this up. You can see this opened up my basic analysis notebook. And so right now what we're going to do is we're just going to acclimate ourselves to the Penguins data set so we can start thinking about what we might want to our Streamlet to contain. So let's see.
Quick question. With mine, it opened up to launcher. Should I double click basic analysis? What is it? Basic analysis notebook on the left to get that to open?
Yeah. So here in this tab, so this thing is sometimes clicked like this. A lot of times you can click this little folder here and open it back up. And you should see all of the different files here. And you can click basic analysis. And then if you, let's see, I'm looking at the chat. If you type specifically what's going on in your Anaconda prompt, perhaps one of us can help you out. All right, so now we're in this basic analysis notebook, and we are just going to take a look at some stuff. So this, So this is not going to be specifically about live coding. About this particular notebook, we're going to get into the live coding with the actual Streamlit app. But so again, this is just to understand kind of what's going on. So let's see, let's execute this. This is Shift Enter to execute. Basically what's going on here is that we're just importing all the packages that we're going to use. So you can see here we're going to use pandas, NumPy. These are both numerical and or tabular libraries. Matplotlib, Seaboard. Those two are very strong plotting libraries. Scikit-learn, we're going to use the confusion matrix and the confusion matrix display. So it looks great. Okay, so now we have those. Now we're actually going to read our Penguins data set. And so I put this is like the actual link online to the website, just in case we had to use Google Colab, but it should still work here. So let's shift enter this one. We can see here that we've read the CSV, so we stored that into DF. And now we're just getting and printing here a little bit of info about our data frame about the penguins. So let's learn a little bit about that. We can see that we have some different columns. So we have two, which, well, we have more than two, but these first two are going to be categorical as well as sex. And then we have some numerical ones about the bill length, depth, flipper length, body mass, and years considered numerical year. So those are going to be the columns of our data set. And we can see that we have a size or 344 rows, but some of them are going to be null. So we can see that we have some 333 non-null, for example, or 342 non-null. And so that means we have a few nulls somewhere in our data set. This likely means that we want to drop at least some of them. So now let's just in general get just a preview of how this data is going to look. So here we're just going to display, so we'll be able to see the data frame and then look at the shape. So again, this shows us a little bit of what our data frame is going to look like. It just shows us the first 5. This is something our users might want to see. Could be interesting. They might just want to know what things are looking like. So we can see that we have some different species here on some different islands. And we have some sizes here. And as expected, we have the sex and the year here. And we have the expected size, which matches this here. So 344.8, 344.8. All right, so we might want to drop the NA and then learn more about what happens after we've done that. So let's see, we've dropped the NA. We haven't lost that many columns. And so that we could probably move along directly with this. All right, so now that we've understood a little bit more about the data, and we think to ourselves, that might be something interesting for our users to look at as well. Maybe we should also show them some visualizations. So then we think to ourselves, what type of visualizations that they might want to see? So quick question for you all. What type of visualizations do you think might be interesting for the users to see about this data set? So again, we have species, island, these different numerical variables, sex and year. What are some interesting plots that might reveal some insight into maybe the relationship between these or what's contained in these? Feelings?
I might want to see maybe a bar chart of male versus female for body mass.
I like that. Those are great ideas. I think I'd also want to see that as well. Anyone else? Thoughts? Again, please feel free to stick things into the chat. All right, Jesse, so I'm definitely with you. I always love to see the different categories or the different levels of each of my categorical variables. So I want to know, like, is this the only species or are there others? Which islands do we have? What's the distribution of these numerical variables? And how many do we have of these different penguins? So let's see. So this is a function that's just written so you can get a sense that functions, you can write functions that can be used in, you can write functions that can be used in your app. So let's shift enter that one to get that into the kernel. And this is basically just going to plot a set of columns based on their type. So basically what it's going to do is you're going to pass in the data frame that you have here. You're going to decide which types of columns that you want to include or exclude, and then some other parameters here, which are a little bit beside the point. So let's see how this functions. So maybe we want to see all of the categorical variables. So here we're saying, hey, we want to include every column that has an object type. That's going to be our categorical variables. And again, don't forget to shift enter this one to execute it. And now we're going to plot multiple here, shift enter. And here we can see We can see a lot of things, but the most relevant is that this is a single row. Okay, this is just repeated twice because of the way that we've done this. I think we can do that. We get just one, perhaps, yes. So here we go. We see the distribution of the different types, or the counts of the different types of species. We can see the counts of the different kind of islands where the penguins came from, and we can see that we're pretty balanced in sex between the different types of penguins. We could do the same exact thing for our numerical data types. And so basically this is saying, hey, we're trying to plot everything in this data frame, but exclude everything that has an object type, meaning include everything that has a numerical data type. And again, I'm just going to put this colon here just so we can suppress unwanted printing. And we're going to shift enter to see the result. And here we can see that we have the distributions of the different numerical variables. So we have the bill length, we can see that it's thusly the bill depth, the flipper length, which is seemingly wanting to be bimodal. We have the body mass, and we have the ears. So these are things that may be of interest to our users if they would also like to know a little bit more about our data set. There's also a lot of different other things that people might want to know. Instead of knowing just about this one column or about this one piece of data, they might want to know the relationships between them. So the way that we can do that is use a Seaboard pair plot, which is just going to create a scatter plot between all of the different numerical variables. So that's what this is. This is using Seaboard and the pair plot function. We're passing in the data frame, and this parameter hue is just saying, okay, I want you to color all the different elements based on the species that they are. So here, if they're a deli, make them one color. If they're Gen 2, make them another. And Chinstrap, make them another. That'll help me visually see the relationships in addition to the type of species that they are. So that was a lot of words. Let's see how this works. So here we go, shift enter. Something interesting about this is that it is not the fastest running, function in the world. In fact, it is the opposite of fast running. And we're struggling now. But it is beautiful when it is produced. So let's see, this is exactly what we wanted. This actually tells us a lot about the relationships in our data, right? So here we have, for example, the relationship between bill depth and bill length. And so we can see the differences among the different species types. We might conclude that these two species have a really similar bill depth. Well, this one has a different one. Or we might consider that this one has these two have a really similar bill length, where this one is slightly different and slightly smaller. These are the kind of things that we can think about and understand as we are looking at these kind of plots, which also may be interesting to our users. In addition, if you choose to do something like classification, these plots can help you understand the model performance and how you might improve. So for example, if you were to look at this pair of bill depth and flipper length, you would see that it's nearly indistinguishable, the Adeli versus the Chinstrap, but separating these two from this one is very distinct. So using this in conjunction with something might help to discriminate two of these. So using this alone might help to discriminate two of these, and then you would probably want to pair this with at least one more thing to discriminate between the three. We can also repeat that with other types of hues. So maybe we don't really care about the differences between the species. Maybe we want to know about the relationships with the island. So I shift enter that one. And we can take a look at that as well. It's going to look very, very, very similar. It's just that, oh, I like those insights. See, we love a plot. It helps us form these intuitions about our data. So here we're coloring instead by the island, and you can see that the plots are indeed different. It seems like the island does not have as much as a separating impact as the others, but maybe. I guess it depends on the ones that you look at. But this is also providing some insight for ourselves and for our users. So this is something that might be very interesting to show on a Streamlit app. Okay, so after we have kind of looked at the data itself after we have seen like these univariate type of distributions, after we've seen the relationships between the pairs, we might try to step into the modeling. So maybe we have this app. Maybe we have this app for some penguin researchers, and we've developed a model that we're going to do some prediction on. What they want is they want to take their tablet around. They want to input the values that are in these columns, and they want to get a prediction on maybe the gender of the or the sex of the actual penguin. Maybe. So what we're going to do here, we're not going to do that, but we're going to simulate that happening. So for example, we're going to generate this test data. So all this is really going to do is just make up some test data for us. So you can shift an image of that one. And again, this is a function, again, to demonstrate that functions can be used with Streamlit. You can see that in our installation, we installed NVDev, and there's a reason for that. So if you use NVDev, you would extract all these functions out, which you'd then be able to use in your Streamlit. And so that's a really great framework for being able to accelerate your workload. Okay, so we executed that one. That's now in our kernel. And let's see what this is doing. So this is generate test data. So we're calling this function, and it's going to generate us a data frame of size 30, but we can see what it's going to actually return here. So it's going to generate some prediction probabilities. So there's going to be the actual probability. So it's class 1, which is the one that we're looking for. Then P0 is going to be 1 minus that. And then we're going to make some actual results here. So let's see what that looks like. All right, we can see our data set here. And we have some prediction probabilities, and we have some actual values that we have simulated. So what is the use of this? Well, as you guys probably well know, with confusion matrices and with classification, you can pick a value upon which you want to determine whether things are one class or another. And so maybe that's the desired, maybe that's some desired functionality that these researchers want. Maybe they sometimes really care about, I don't know, precision, or I don't know, maybe they just have some different desires at different points, and they want to be able to tune it on their own. So this function is made to do that. So basically what this is doing is it's getting the prediction class. So based on whether your prediction probability is greater than some threshold that you pass in, the default is usually 0.5 for all like modeling packages. It's going to predict the class, and then it's going to create a really pretty confusion matrix. So let's see. We're going to run that again, shift enter, and then we're going to use this tune threshold function on our predCF with the default threshold. Then we're going to plot that result with this really nice looking color map. All right, and we can see that at the default threshold here, we have some false positives here. We don't have any false negatives, which is interesting.
So this is sort of like pretend model and pretend, just so we can sort of see what a machine learning algorithm would. It doesn't matter really what we're doing. We're just doing some data science here that we're going to share on Streamlit. Is that?
Yeah, we're just doing, that is such a great phrase for that. We're doing some data science that we're going to share on Streamlit.
Okay.
Yeah, so this is not the specific, this is not the modeling, and this is just to make some data and show some types of functionality that could be interesting to use on Streamlit. Also, do keep in mind that we cloned this repository, and so there are some limits on how large the data is that you put in there. And so if I were to put in a really huge model, that might not have been the best for everyone. So this is really just to simulate a lot of those different things. So here, this is really going to hammer that down, how much of a simulation this is. So this is something that we do with our machine learning models that we predict. And so when we predict, we pass in some input vector that goes into our model. And here, since we're predicting class, we're also going to use the threshold, right? So here, we don't actually even use the input vector. We just make some value up, get some random value, and then we assign a label based on that. So again, this is really just to simulate some of the behaviors of the things that we do in data science, but it is not like the actual use of the model or the actual data that we have. So let's see how that works. So let's run that one, and let's get our prediction. based on just something and get our predicted class. And you can see based on this input vector, we have male being predicted. Okay, so now that we have some general sort of understanding of the things that we might try to do with the Streamlit UI for maybe our researchers or whomever, let's try to make one. So let's just take a second and look back one more time. So what we did is, and again, I just clicked on this little dot, dot, dot side because I don't want to make you seasick with scrolling through all of this. Basically, we just did a basic analysis, meaning that we just kind of looked at the data to understand what was going on. We made some general, ooh, that's a good question. We made some general visualizations about each of the individual columns. Then we looked at some pairwise relationships. We looked at the effect of a threshold on a confusion matrix, maybe if we wanted to pick that threshold. And then we looked at what it would be like to use our model and predict and get an outcome. And so these are the things that we might want to do on our Streamlit app. Okay, so let's see how we could do that. And someone asked a really great question. Are we using the Streamlit libraries or Seaboard to create these graphs? Is one better than the other? I'm actually not sure about that. So we, in this particular example that we're going to do, we are using Seaboard and Plotly to demonstrate that that's possible, and Matplotlib to also demonstrate that that's possible. And so we're using those as kind of the plotting packages. There are other packages, or there are other functions through Streamlit that are available, but perhaps they don't encompass all of the functionality that you might be available to you through something like Seaboard or Plotly. So they have the back end available for all of those things, particularly for that purpose. Also, I think this is, so Streamlit is to show off or create a user interface for the work that you've done. And most of the work that would be done would be using like Seaboard or Plotly or something to visualize. And it's good that they already have like those wrappers or that containment. So people don't have to switch their plots from now Seaboard or Plotly over to something else. And someone asked their threshold results were different. Is that normal? That is such a great question. So we said before that we're just kind of simulating this, and that is actually a great question because it's about to come up in a second. But with generate test data, what we're doing is we're just using some random values here. So it's going to randomly produce some things, and this is also a set of random values. So this is just really to simulate kind of the data that one might have. And so we would expect for you to have a little bit of a different threshold or different results, particularly because I didn't set a seed as well. So we would expect for these values to be different. These values to be different, and these values to be different. So that's a really great question. All right, so are y'all ready to kind of walk into Streamlit? I'm pumped. I'm pumped. So we're gonna probably walk into Streamlit just a little bit, get you started on a hello world, and then take a short break and then come back. Okay, so here I'm actually going to split this screen because, as I said, we're going to be really heavy on the API. I'm going to put this one over here, put this one here. If you're having trouble seeing this, just let me know and I will unsplit it. Okay. All right, so let's take a look. All right, so now what we're going to do is we're going to come back to this little folder thing. We're going to open that up. Didn't I just close that? Yes, I did. And now we're going to go to this pin UI. What is that? Well, if you recall, we said that Streamlit likes to run a Python file. So now we're going to start writing that exact file. So I'm going to close this back just so I have a little bit more space. And the first thing that I'm going to do is exactly what they told us to do. So coming here, actually, I'm going to. So coming here, again, this is the getting started. We're clicking on that one. It says, hey, create your first Streamlit app. That's what we're going to do. So we're not going to call it first app.py. We're going to call it pin UI for Penguins UI. And then we need to do these things. So we need to import Streamlit as ST. We need to import NumPy as MP, import pandas as. So they've said here that really they're just implementing or importing these things here just because we use these so deeply in data science that you might as well just know that you're going to do it. But you wouldn't necessarily need to put that there. So now that we have those, what can we do? It says that we're going to run our first app, but we're just going to take one step before that, and we're going to write something. So we're going to use Streamlit. We're going to do st.title.
Quick question, could you zoom in on the Jupyter Lab notebook just a little bit?
There we go. Is it more?
That might be good enough.
Okay, thank you. All right, so we're going to do a title, and then we're just going to type in quotes, hello world. Okay, and then make sure to save it. So I just do Control S. OS X users, Command X. Okay, so what now? All right, now it's saying run your app. A new tab will open in your default browser. It'll be blank for now. That's okay. Interesting. How are we supposed to do that? Well, whenever you see things that look kind of like this, usually they end up happening in a terminal. So that is what we are going to do. We are going to open up a terminal. Let's see, new. So we're going to go up here to File, New. Then we're going to go down here to Terminal. We should see a new terminal open up. Mine's just going to need just a second to get itself together. Right now it's just blinking, but it needs to show an input. All right. So OS X users, you usually don't run into this problem. Yours tends to open to the environment. You can see here that for me, this opens into my base environment, which is something I don't really like, and it's not actually helpful for me right now. So I need to activate my environment. And again, OS X users, I don't think this happens to you. But if you're in Windows, take a look at this. If it's the wrong thing, you know what to do. On to activate Streamlit imp. All right, so this shows us that we're in the right environment. And the reason that we need to be in this environment is because this is where Streamlit is for us to run. So now we're going to do what it says. We're going to type Streamlit run and the name of our app. Streamlit run. What do we call it? PinUI.py. Looks like it's thinking about some things. Hopefully it's having good thoughts. Sure, no problem. And so basically what's happening here is it's starting a server in the background and it's running our Streamlit app. At least it's trying to. Let's see if it makes it. Oh my goodness. So this is pretty exciting. So here we can see that we have our title, which is Hello World. We can see that we're running on a local server and we are made with Streamlit. So this is our first. So rolling back, so which part are we repeating? Are we repeating the penguins part, this part? Are we repeating the how did I open Streamlit? Great question. So here on Windows, again, sometimes it opens in the wrong environment. So this is the base. It's not the environment that we want to be in. If you find that this is the case for you, just type con to activate Streamlit imp, just like we did to even open up Jupyter Lab in our correct environment. Then after we see that we're in that environment, we're going to type Streamlit. Unfortunately, that is in this yellow color, which no one can see. Streamlit run, and then the name of our Streamlit file, which is called PinUI.py. Streamlit run, PinUI.py. Then I clicked enter. Now, some people, you may get something that pops up here that says, hey, enter your email address if you want this, that, and the other. You don't have to do that unless you just so want that. And then at that point, you would click enter if you don't want to put anything in there, and then this should show up similarly. So now we have our first hello world. We can see that st.title allowed us to print hello world in a specific case type, so a title case. to our app. All right, so we're going to take a brief break until maybe noon, and then we're going to come back. Maybe a little bit. No, we're going to come back at maybe 11 or 12:03. Come back at 12:03, and we're going to foray deeper into the world of data science and Streamlit. I'm going to pause recording, and let's start back where we left off. So I'm going to go ahead and share my screen. And here we were. So we had our first hello world in the title case. Before we jump back in, I just want to let everyone know. So the repo here, in case you happen to miss something, you can always go to these Pin UI solutions, and they have everything that we're about to do. However, they have more than actually we're about to do, in case you want to go back and look at this as a reference. So if you just need to run this, please feel free to do that. Otherwise, try to live code with me, because this is very exciting to see all the updates. Okay. All right. So here again, we have our hello world. And now we're going to actually start with our Penguins app. So there's a few more things that we're actually going to import. So as we said before, we had all those functions in the basic analysis notebook, but we want to use those functions also in our app. So we have this basic analysis.py. Again, that's the kind of thing that you could create using NBDev. And so this is just going to contain, sorry, this is going to be like real tiny. This is going to contain all the functions that we had before. So we had plot multiple, generate test data, the thresholds, and the predict. So this has all of those things. So we are going to want to import that as well. So to do that, we're just going to type import basic analysis, from basic analysis. We're going to import everything. And also in this example, we're going to use Plotly, which is very exciting. So we're going to import plotly.express as px. And that's just a really great way to plot things with Plotly. All right, for our title, let's go back and change that a little bit. So maybe.
Can I ask, so really NBDev works really nicely with this sort of in concert. Yes. So is the idea kind of like, so you do your analytics workbook, and then you do the NBDev to create the importable script, and then that's what you create a different script for the UI part. Is that kind of how we should think about it?
Yep, Jesse, you nailed it. That is exactly how we should think about it. So making the analysis with your nice markdown and your exploration in your Python notebook, but as you're writing that functionality, being able to use it elsewhere and making that possible through using NBDev. So that is exactly the exact workflow that is just absolutely fantastic.
Great. Thank you.
Yeah. All right, so let's pop into this title. So as we know, we can change this. This is just a little string. So maybe we want to title it Exploring the Penguins data set. And we also saw that we can use this st.write. It says that that's kind of the Swiss Army knife, but you can also just write things directly. But let's see what st.write looks like. So we'll do st.write, and then we'll just write something. So maybe learning a little more about penguins, or whatever you'd like to put there. So let's see what this looks like and how that works with our UI. Like, do we need to start things again? Let's just see. So what I'm going to do is I'm going to save this, Control S, make sure it updates. Then I'm going to come back to the save site that I had before. And so something really good to do is just to leave this open. Otherwise, you always have to type in this address again. And so I'm just going to come back here. And oh my gosh, oh no, there are no, nothing has changed. So what you can do actually is click refresh. And here you'll see that it's running again. And again, it's really not usually this slow. I think it's slow for me because I'm also running soon. So here you can see our updated updated behavior. We have our title case here, and we have what we've written here. So just a little side note, this hamburger here actually provides some really nice functionality. So you can always rerun. You can learn a little bit more about the cache in the data or in the actual API. You can have some other functions here. In the settings, it'll actually allow you to refresh every single time that you save your Py file. I just don't do that because for some reason I don't know, I just run into issues. So I just come here and I just refresh every single time to be sure. So let's go back. And we said before that we were doing is we were thinking, okay, let's show people a little bit of the data. So let's do that. So because we have a UI, maybe what we want to do is make some nice headers. So we do have that functionality. And so here I'm actually going to pop right on over actually to the API reference, because we're going to start using that pretty heavily in just a moment. But some things I'm just going to just outright show you, and you'll find it kind of there. Oh, nice. Actually, it's right there. So we had Streamlit.txt, or no, we haven't used that one yet, but that's something that's available. But we can see we have title, header, and subheader. So we're going to grab the header functionality. So st.header, and we're going to do basic data structure. And that is actually going to be matching actually what we put in our Python notebook. So now maybe what we want to do is show the data. So how can we do that? Well, actually the same way that we did before. So what we're going to do is we're just going to create our data frame with read CSV. And we're just going to use our local pigments.csv instead of using the one from online. So you can see here, we actually popped that one right into the repo. I'm just going to close this down. So now we've read the CSV, and now we want to be able to show it, right? So how can we do that? Well, they said that write was the Swiss Army knife of showing things on Streamlit. So let's try that, st.write, and let's just type df, see how that goes. So now I'm going to save that again. Come back over to Streamlit. It tells me that the source file has changed. It asks me, hey, do you want to rerun this? Do you want to always rerun this? You can click any of these things, but I'm going to click refresh. Here you can see that it did exactly what we wanted. So we have our title, some writing, our header. You can see that this is a little bit of a different format, and then we actually have our data. And so we can scroll across and kind of see things there. Also, there's a little tab over here that you can't really see on my screen, but you can also make this full screen in case you want to look a little bit deeper at it. So maybe we also don't want to show this the full data frame. Maybe you just want to see the head. We can do that as well. That'll just short things up for people, but you can also leave the full data frame there as well.
So one thing that's a little bit weird for me is, so I typed instead of header, I typed hearer. I just mistyped it. And then I saw the error stream on the web page. So I guess that Streamlit is always running the background, detecting when you save a change, and then trying to sort of rerun the code to update the web page.
I love that point. So that's exactly right. Something that sometimes I just come and look at is this. It'll also pop errors over here sometimes. So if you run into errors, you can see them populated in this actual document here. So this is a lot just like how Jupyter works, and that it has the server that's running in the background that's kind of already always attending to your needs. All right, so now we have the title and we have showing the data frame. I'm just put some comments here because I myself get confused about things. All right, so, and then these comments are just regular Python comments, so they don't show up. So here, I'm just going to show data, and let's see. So maybe we then, what was our next step? We actually ended up cleaning the data, right? So in the sense that we removed NAs, maybe we want to do that here as well. But maybe we want to give the option to clean the NAs. How can we do that? Well, what we can do is, again, this is a UI. We might want to make this look nice. So we're just going to add another header. And we're going to say maybe optional cleaning operations. Maybe we want to give them a button that they can press to clean the data. Let's see. But what would a button be? Interactive widget? That sounds buttony, right? Let's see. Interesting. Oh, and it's the first one, a button. Okay, so it says we allow to fake interactivity with buttons and these other things. Oh, it looks like there's a lot down there that for us to look at. Well, let's see how we can use this button. Well, something also I like a lot about Streamlit is that they give you examples. So here they say you just have this button, you have this input thing. What is that? Well, that is a label. It's the first thing, a short label explaining to the user what the button is for. Okay. And then it says if that button, so that means if it's clicked, then do this thing. If it's not clicked, then do this other thing. Okay, so let's try that for ourselves. What we want is if the button is clicked, we want it to drop the NAs. And that's just kind of the story. There really isn't an else. So let's see. Well, we're going to do what they did. So if st.button, maybe we want our button to be called remove NAs. So if that, then df.drop NA. This is exactly what we had before. In place equals true. Maybe we want to tell the user something, give them some feedback that something that has happened. So we know that we have this st.write, right? So we can tell them that st.write NAs. Maybe we want to say the new data size is, and give them the new data size. So something that's nice about this is we can use this a lot, like we write print statements. So we can just write a comma there and then say the thing that we want to print, which was Lynn. Yeah. All right, so let's save that. See how that goes. So again, what do? We made this button that has remove NAs on it. If we click that button, then we're going to drop the NAs and write this thing. Let's see. Save. Come back up here. We're going to refresh. All right, now let's see if it's working. So optional cleaning operations, let's click it. Does something. Okay, great. The new data size is 333, right? And we knew that to be the case because that's what we found before in our notebook. So this is going to really relate to something that Jesse just said. We're just going to do something real quick so you can see the behavior of this. So here in the show data, we're going to use that magic function where we're going to print the size of the data. So let's do in row orig equals lid of df. This is going to be the original data frame, right? All right, and we're just going to write that. And so then if we click this, this should write something else. So let's save that one. Take a look here. We're going to refresh. All right, so this starts out with 344. We're going to click remove NAs. And we're going to get this 333. So keep this in mind, these two values here, they're quite interesting. In a moment, we will see, we'll just keep an eye on this because we're gonna observe something interesting. All right, so now we have our button. We've removed the NAs like we thought we were going to do. And now let's start with the visualizations. Okay, so let's see. Basic, oh, nope, I didn't make it there. Oh, nope, nope, nope. All right, so basic data visualization. We're going to make another header. And let's say call that basic data visualization. Let's write a little something. Let's say maybe look at data distributions. And maybe since we have different types of distributions, maybe we want to make a subheader. which is nice. We saw that in the API. I'm going to say these are categorical variables. And now we're actually going to use that function that we wrote called plot multiple. We're going to use it actually in the same exact way that we did before. So we're going to have fig, which is what it returns. And we're going to just call plot multiple. And then we're going to pass in our df that we had. So just like before, we're going to say include equals object, meaning that we only want the object data, column types. And we're going to use this parameter fig size that we baked in to make sure that it looks good. Then let's try st.write, because supposedly it's a Swiss Army knife of things. And we're going to write fig. So let's save that one. Let's come back and refresh. Oh, interesting. So it didn't like that. So here we got the error. It's saying, hey, what is this? This doesn't look right. There's a reason it doesn't look right, because I made an error. Fig size is actually is a keyword, and you're supposed to give it a tuple. So it should be fig size equals 9.4. Save that again. Round 2. Source file change, great. Refresh. And we're still running. And we get our results here. So now these are the same categorical variables that we had before, and we can see them kind of laid out here on our UI, which is very exciting. At least to me. Maybe you guys aren't excited, but I'm very excited. So something interesting to note is that when you refresh it, it kind of just runs again, right? So here we have 344. We've never removed anything. It thinks that we've started over, which is fine. So now if we remove NAs, it actually runs everything again, right? And it will produce slightly different. So now we're back to this, and this is affecting this as well. All right, so let's just repeat this for our numerical variables. So should I do this? Yeah, I'm going to do it.
I have a quick question. So see, we clicked removed NAs, and that caused everything to rerun. Does it rerun everything, or does it look for dependencies of the things that must be rerun?
So it reruns. I believe that it actually reruns everything. It reruns things from top to bottom. Okay. But there are ways to get around that. And so you can see that there is some consternation a little bit about the performance of this, which we will see if we get to the Seaboard part. It will be the struggle will be very clear. And so they actually do have some performance things that they add that you're able to make things be cached so that everything won't run every single time. So this is a clear cache, so that you can remove things from the cache, but there's also caching that you can build into your Streamlet app so that it won't rerun everything. But it generally runs most things.
Streamlit makes it really simple to get things like immediately, sort of at the expense of not doing where you don't have a lot of control necessarily unless you take extra steps. Mm-hmm. And tomorrow we're going to be taking a look at Shiny, and Shiny is harder when you get started, but then it's more conservative and only runs the stuff it needs to rerun. But it's almost like that's the trade-off: mm-hmm. Getting started quickly, but then having to do some extra work, versus harder to get started, but then you have more control. Interesting.
Mm-hmm. All right. So I will leave you to try to do the numerical variables on your own in the future. Again, the results, like how to implement that, is actually in that in the repo. But basically, it revolves around just changing this word include to exclude, and then you're done. Okay, all right. So that is how we can plot something. Just create a plot keep in mind that you don't actually just have to use this right function. There are other functions that you can use to implement this. So let's look at display charts. So someone was asking before that they saw like the Streamlet charts. You can see that this is not really a Streamlit chart. It's more like an Altair chart, but there are different charts that you're able to specifically create. So we have line chart through Streamlit, area chart, and bar chart. But then we have actual interfaces to different packages. So PyPlot is about matplotlib figures. Oops. We have Altair charts, we have Plotly charts. There's like a lot of different charts that are available. So just keep that in mind. So instead here, we could have definitely also written PyPlot. All right, so now let's look at some different types of functionality. So here we had a button. We've shown how to display data, like data frames. We've shown how to display plots. Let's look at how we can add a little bit more user interaction. So here, let's say that maybe our users, they don't actually like, maybe we think that our performance on the Seaboard plots is going to take too long to render. So we're going to say, okay, well, let's let the user decide which pairs of plots that they want to see. So let's see how we can do that. So let's make another interactivity area. We're going to make another header called interact. And we're going to instruct the user, choose two columns to view the interactions. Okay, interactions really isn't a great word, but that's for relationship. Let's go with that. And so now we kind of need to provide them with this kind of like drop down menu type behavior where they can select the appropriate columns to plot against each other. So we could have them write like in a text box free-handed, but that would not be a great user experience. So let's see what they have here. Let's go back to interactive widgets. No, but doesn't sound right. Checkbox, that would be a lot of different checks. No, maybe don't want that one. Radio button, maybe. Select box, what is that? Well, this is not the most descriptive thing in the world. However, it is a box that allows you to select things. So it's very drop down menu-ish. So let's see how that looks. Okay, let's see how that looks. So we do know that we're going to have to pass in a label and some options. So label is what we expect, just like the button. What is options? It's going to be a list, a tuple, ND array series, or pandas data frame. Label for the selected options. Okay. Let's maybe try the list because lists are awesome. So what we want them to choose from are the column names. We can get that as a list. So let's get that as a list. We're going to call that call vars. We're going to do regular programming, data science, pandas stuff. So df, that's the data frame that we have. We know that columns tells us all the columns that we have. And we can also just create a list from that. It also did say that it allows you to receive series data frames, but I think actually columns is an index. So let's do it thusly. We're going to make this into a list. So now we have this element that we need. And so we only actually need these two. So we can put the label there, and now we have the options. Okay, so let's see how we can do that. Well, we're going to have to plot something on the x-axis. So we're going to call that x bar. And we're going to get that value from the select box. So from st.selectBox, where we're also going to specify exactly what we're going to put into it. So we want the label to be maybe x variable, and then the options are going to be call vars. Well, we also need to do the same thing for y variable. So let's see what that looks like. Y bar equals st.selectBox. We do that for y variable, and it's actually going to be the same exact selections to pick from. Okay, then what are we going to do with that? Well, what we're trying to do here is pretty much make a scatter plot. So let's make a scatter plot. And we're going to do that using Plotline. Why? because we can. Also, Plotline has really great like hover behaviors and things like that. So maybe what we wanted to do is use Plotline. So we need to return a figure usually. So the figure that we're going to return is called scatterplot. And we're just going to use px. If you recall, this is plotly.express, and we import that as px. So now we're calling a function out of plotly, and we're just calling scatter. And what plotly wants to know is what the data is. So df. It wants to know what the x variable is that you're trying to plot. Anybody know what the x variable is that we're trying to plot? What should I put here? What's the name of that variable that we're trying to plot? It's dependent on the user input, right? On the value from the select box. So when the user selects something from the select box, it's written into an output. So here we have the select box. The user will select it and it'll be written here. So it looks like X bar is the variable that we're looking for. And then it also wants to know the same thing about Y, which is going to be Y bar. Then we're just going to demonstrate the functionality of plotting using the Plotly chart. And again, we're just going to come here, see if there's anything specific that it wants from us for the Plotly chart. Let's see. Oh, that's an Altair chart, Vegalite chart, Plotly chart. Looks like it only requires this figure or data. And how do I know that? Because it does not have a default argument like this. So if it has this default argument, that means that you don't necessarily have to specify it, but we do have to specify this one. So what we're going to pass in is this scatter plot. So let's see how that works. We're going to call st.plotlychart. Is that right? Yeah, plotly chart. And we're going to pass in scatter plt. And that should print for us. All right, let's see. Let's save this one. Come back, look at this. I'm going to try this, rerun. We're going to see how this works. It's a little faster. Maybe that actually does cache things. Yeah, maybe not. We'll see. Oh, one titty soul. Interesting, right? So this is exactly what we asked Plotly, or we asked Streamlit for. We wanted an X variable, and we wanted a select box, and we wanted it to list all the things that were in the columns, and we wanted to do the same thing for a Y variable. And then we wanted it, whoops, then we wanted it to plot something. All right, so let's see what happens when we choose something else. So maybe let's choose bill length. Oh, it updates. The whole thing, it updates. And then let's look at, maybe we want something different than species. So let's choose bill depth. And now we have a plot based on what the user wanted. So now we've learned how to use the select boxes and have them, the outputs of them, so the selections made by the user, as inputs into a function or some kind of plotting that we want. And again, this is the awesomeness of Plotly. As you can see here, it shows a hover over of some information that we'd be interested in. So let's just explore something again right quick. 344, let's remove these NAs one more time. Okay, so now we're at 333. And it ran again. So let's see what happens when we change this. Let me just, for my own benefit, I need to see this for myself one more time. So now it made this, but it actually undid this, right? Because it ran all over again. It ran the whole thing all over again. So what happens when we need this to persist? What happens when we need this remove NAs to persist? Something to ponder. Is it possible? Has anyone ever ran into this in the history of Streamlit? Yes, they have. And there's a way to do it. And we will talk about that if time prevails. Otherwise, we will look at it more. You'll be able to look at it more because it's very strongly within the solutions in the repository. But we will come back to this. But this is something just to keep in mind. It really wants to run this from top to bottom. although sometimes it appears to keep the values that you have selected. All right, so rolling back. So now we've given the user the ability to look a little bit more about relationships that they're interested in. Maybe what we want to do now is get into some of the modeling aspects. So say, for instance, we've already created a model, and now we are trying to determine maybe the threshold that we want to do, like classification, where we want to say something is positive or negative. All right, so now let's implement that functionality. And maybe the best way to do this is, we know that the values are bounded between 0 and 1, what the threshold can be, because it's a probability. Maybe we just want to be able to slide a slider and then see the behavior or how that affects that confusion matrix. We're going to adopt that approach. We're going to adopt that. We're going to see how that goes. All right. So now we're going to work with the model. I'm going to scroll this up a good bit. We're going to make another header because this is a UI. We're going to call this model. And we're going to write, choose a good threshold for classification using the slider below. So now we did something similar before, where we had this element, the user, right, the user picked a value, and then we got the value out of that, and then we used that value. So now let's try to do that for a slider. Let's see what that looks like. All right, so see button, checkbox, try to get to the slider. And multi-select something. All right, there we go, slider. Okay. Okay, so we know we need at least the label. Great. But we're probably going to need these other things. All right, but we can see. So we're going to display a slider widget. We can do these specific things. We can show those things. Oh, we can render a range slider. And we see some differences here. These are things that you can read as you go into the API. So let's see. We know that we need to implement a slider. We also know that that slider is going to dictate the value that we're going to have for our threshold. And then we're going to use that threshold to generate confusion matrix. All right. Yeah, that's what we're doing. Okay, so let's see. Thresh val. We're going to use this st.slider. Let's see. We're going to give it some kind of name. So select threshold. Then we might need to specify these things. All right, so min value is the minimum value that you're going to allow the user to use. Defaults to 0, the value is an int, blah, 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 and these things. So we're going to specify this anyways, even though it is 0. Min value equals 0.0 to demonstrate how it's done. Max value defaults to 100 if the value is an int, 1 if a float. We're going to specify that ourselves. Max value equals 0.99. Value of the slider when it value of the slider when it first renders. We are going to use the standard default threshold that most packages use. So let's give it 0.5. Step, that also sounds really interesting. The stepping interval departs to 1 or 0.01. We're just going to explicitly specify that one. So we're going to say the step is going to be 0.01. So when we click our slider and we're moving it, that basically means how far it goes within each little click. All right, so now we have our threshold value out. Now what do we need to do? Well, we actually need to do the same exact thing that we needed to do before. So actually, I'm just going to go back to that notebook right quick. So basically what we did before is we just called this tune threshold on some prediction data frame, and then we plotted it. Okay, well, let's do that. But that does mean that we need to get the prediction data frame first. And we know how to do that because we also did that before. We just use this generate test data. And so in your regular workflow, this might look more like load test data from like a train test split or something like that. But this would also probably be your training data as well. It wouldn't be your test data, it'd be your training data. Anyways, it's neither here nor there. We are just going to generate this and then again, use this tune threshold to pass in our threshold of interest and see its effect on the confusion matrix. So let's see what that looks like. So pred df. So that's the data frame of predictions that we need to get. Generate test data. Here we're going to get the prediction data frame. And then we want to get the confusion matrix. So we're going to call to threshold on it, on our data frame, which is going to be pred-df, and our threshold is going to be that which the user passed in. So it's going to be thresh val. And awesomely, it's going to start out at 0.5. Thresh val. Then we are going to plot that. So this is a little bit of a special situation with this particular plot type. So do keep in mind if you run into challenges when you're plotting, there may be some workarounds that you need to implement. But here I'm going to show you a really great one. So you'll just be a little bit accelerated for the future. So with scikit-learn, they have something interesting about this type of plot. But do recall that Streamlit does like to use its magics to print things directly. So we're going to call things like we normally do. So we're going to call this .plot. And that's what we called before, to plot things. And we also use that cmap function just to make it a little bit prettier, rd.edu. And then we're just going to use this field of this particular function called figure. So nothing is infallible. There are some weirdnesses that happen sometimes with matplotlib. Often you just have to figure out how to get around them. So let's see how this goes. Control S. Let's reload this one. We're going to make it. We're going to make it. All right, and there we go. So now we have our confusion matrix that we wanted. All right. Try this out. Try it out and see how it works. So let's see, we slide that up a little bit. Interesting that it's taking some time there. Interesting. So 18318. Okay, these seem to be working pretty fast. So there's something a little bit suspicious about this behavior. And due to the speed that this is actually rendering, it's hard for you to see because you would have to kind of look at it kind of at length. But I'll give you the punchline to this, and it's exactly what we noticed before. This Streamlit will try to run everything all over again, right? So we're trying to run things all over again, meaning that we are going to be calling this generate test data over and over and over, right? And so I think someone brought this up before about how their results were different from our results because we have it's differently initializations and different values from the random number generator. So basically every single time that we're dragging this, that we're dragging the slider, it's generating a different data set. And so we can't like look at it too far in depth right now because it's just taking so long to run because of Zoom. But that is the case, that it is generating a new data set. So how is it that we're going to impart like this persistence with between runs? Like we just drag our slider, like certainly that value should stay consistent of that data frame. Like it shouldn't be running that same thing again. Certainly there must be some way. Well, it sounds like what you want is for the thing to maintain its state. State, that's an interesting word. Let's see if anything here can help us. What is this? Add state to your app. Wonder what that could be. Let's look that one. What is state? Streamlit reruns your script from top to bottom every time you interact with your app. Each rerun takes place in a blank slate, no variables or shape runs. So this is really what we're concerned about. And so session state can help us to make things stored and persist. Okay, so how are we going to do that? Well, we're going to take a look at what they've told us to look at. So basically, they've given us an example here. And so you can go back and review this, but I'm just going to give you a general overview. Basically, they're saying, look at this counter. The user clicks the button 1,000 times, but the counter actually never implements or increments. The reason being that every time you click that button, it just resets back to none, to 0. And so the highest that you'll ever get is 1. But you need that value of the count to persist. So how do you do this? Well, they give you an example. They tell you pretty much exactly how to do it. So basically what they say is you need to formulate this key value pair, right? And you need to store that key into something called the session state. And that will help that value, or that will cause that value to persist. So if the key isn't in the session state, so for example, the first time you run it, that means that you're going to put the value there. And then after you run it, you will always have that value because this will no longer be executed. It won't be updated. Let's see what this looks like. Oh, let's not do this thing. Oh, well, this is what it looks like here. So let's see what that might look like for us. All right, let's see. Let us ponder. Let us consider. So we do know that we need to do something like this. We need to set some kind of key. Let's let the key just straight up be preddf, right? We'll just let it be that. So now we just need to say if preddf not in st.session state, then set that preddf to be equal to a value. All right, let's give that a try. We're gonna set it here. If preddf not in st.session state, then we want to give, we want to give it a value, which is that one. And then we want to store it. Okay, so let's store it st.session state.preddf equals preddf. Then after that, we would want to use this in the future. So now we can just do that. We're going to take that, copy it, stick it right on there. Let's save that. So I encourage you to look at this a little bit further. I'm going to rerun this by the way. I encourage you to look at this a little bit further and examine this behavior because this is pretty important if you need things to persist between moments. This should also give you insight about what one can do in order to fix the situation that we had about removing the NAs from the data frame above. You would want that removed NA to data frame to then persist. And so that's something to think about. And these are ways that you'll be able to implement that functionality. All right, so now we have this. You'll just kind of have to take my word for it here because this is really a little bit too slow for me to kind of demonstrate. But now let's see, this would allow us to pick just the right value of our threshold. And we can now use that for prediction. So now we have our model and we're going to make a prediction and we're just going to pass in the threshold that we've chosen. And that's going to tell us whether our penguin is, for example, male or female. So let's provide the ability to actually do prediction. Okay, so let's see. So let's make that section. And what we're going to do is, again, what we want is for the user to be able to input some specific values for prediction. So we're not going to write out all those values because that would take us like a super long time, but we're going to pick maybe 3. We're going to let them pass in 3. And so what we can do is let's let them pass in species and island. So those would be 2 categorical variables. And then let's allow them to pass in the mass, which is something that they would either be able to type in or like, I don't know, select. So we know how to do this with the categorical variables. So we're going to have this output that they're going to pick. We're going to call that cell species. And we're going to let that be a select box called species. And then the values that we're going to let them have is going to be df at species. So basically, this is all the unique values as a list. We can do the same thing for island, cell island equals st select box, just what we had before. They're going to select the island, and we're going to give them the options of all the different types of islands that the penguins came from. But then we need the cell mass. This is a number. What is the right widget for that? Well, you know what time it is. API reference. Pop back on over. We already said interactive widgets. Let's pop on over to, let's examine. Okay, we don't want radio, not select box. Multi-select, no, we want something that specifically relates to numbers. Slider, we could slider it, but it'd be nice to be able to type things directly into it. Select slider, no, that's not exactly what we want. Text input, that's kind of close. Let's see if there's anything better. Number input. That sounds good. Number input, let's try that out. Label, we know that we're going to have a label like this. Is there anything else? Well, that's all we need actually. But we can add, okay, we will want to add the min value. We will want to add the max value. And we will want to set the default value here. We could set the step. And actually we would want to set the step because the size, like the mass of these penguins is like not small. So let's see that. So let's just do this. So st dot, what do we say? Number input. We're going to do body mass g. So this is the value that they're putting in. We're going to select the min value. We're going to select the max value. These are things that you would probably pick off of your actual data, but these were picked off the data, but just not here while you're looking. And we're going to set the value to be 2,500. This is just the default value. Okay, so when they get, all right, so then they're going to make those selections. Then we need to put it into some form to pass into our model. So let's do that. We're going to call that pred input, and we're going to make that into, we're just going to make that into a dictionary. Species is going to be cell species. Island is going to be cell island. And then body. G is going to be mass. We're going to pass that into our model. We're going to have sex equals penguins predict. Using our model now on our pred input and our thresh val. What is thresh val? That thing that we picked from the slider. Awesome. And then now we're going to just write to them what has happened. So st.write based on your inputs and a threshold of, pass that in. Freezing up. The predicted penguin sex is, we'll add that there. All right, fantastic. Hopefully that all that syntax is right because that was a lot of writing. All right, so what did we do again? We got species, island, and mass from these inputs. We created our input to our model. We called the model a very bad model. We called our model and we passed in our thresh value, which is going to determine whether our probability is going to be male or female. We stored that value here and we wrote it out. Let's see how that goes. Let's just rerun this guy. I knew there was going to be something. It's inevitable. It doesn't like something in that line. Let's go back and fix it. doesn't like this extra comma. The predicted. Okay. Make it all right. So first of all, it runs straight through. That's number one. But we can see we have our options here. We can pick maybe Gen 2, and it repredicts. And it runs the whole thing again. We can do pick Torgensen, and it repredicts, running the whole thing again, which is okay. Depends how fast your things are running. But again, there are ways to add in performance improvements. The last thing I'll say is there are many other things which can be done here. The first one that I would point out to you is that you do see that changing each one of these causes a new prediction. If your model is not the fastest thing in the world, it has to run the whole thing again and then do the prediction. There are ways to get around this. I love this control flow widget. Actually, that's not what it's called. It's lay out your app. So it's this one. This basically means if you make things into a form, it will put these three things together. You can change these three things all day, and it won't rerun anything until you click the submit button. And how do you do that? How do you make that work? Well, they have this glorious example, and it's going to look a lot like what we have anyways. It looks almost identical. That's going to look pretty identical. So basically, you have all the things that we have right now. Like here, you'll add this new submit form button, which will be submitted. And then when that is pressed, then we would do our prediction. And essentially, you wrap that in this with statement, which is essentially a context manager, which allows this form part to apply to only this part. And so it does something really beautiful, like it wraps things around, and it looks just really great. So let me show you just a few more things lastly. I think we're running out of time a little bit here. Basically, what I'm going to do is I'm going to open up another terminal. Actually, you might not see it because it may take too long to render. So this one is going to try really hard to run the solution, so you can see maybe a few more things that you're able to do. However, this does have the Seaboard in it, so we might not even see this by the end of our time. But there are a lot of things that you can do with Streamlit in a very straightforward manner. You can see here that we pretty much have like a fully functioning app in the hour that we sat down to do this. So these are the things that we already kind of talked about. Let's see, we have our categorical variables, our numerical variables. Woo, we're gonna make it. This is something that's pretty exciting. It allows you to have like these kind of drop-down menus. Not drop-down, but they basically expand. So instead of just being like here and expanded all the time, like these are, you can decide whether you want them expanded. This is actually where the Seaboard is, which is why it's taking like a really long time. But these are the kind of things. Oh, we have a little bit more. Also, another thing is that we before had these kind of below each other. You're able to actually format them using the beta features to be beside each other to save a little bit of size. Else, so let me actually expand this. And here, you can also see that we have these sidebars that are available. And this is the form that I was talking about. This actually needs to be moved elsewhere because you can't even see this. But here. This is also a column selector. You're able to do these things and then submit. And so you're able to have a really nice sidebar as well. So what I've seen people do a lot is have a lot of like information here about their particular project. In here, they perform the predictions, or this is where the settings are made for the calculators. And this one is not using any caching yet, but I think that would really help it with this functionality with Seaboard. All right. I think that you have seen a lot of the things that are possible, and actually you've pretty much made a Penguins dataset app. Whenever you're interested in deploying it, you can use this button, but recall that you do have to have an invitation for the actual Streamlet server, but there's lots of tutorials online if you need to host elsewhere, like on your own local server or on Heroku or something like that. All right, let me stop sharing. And what questions do you have?
Most likely for the instructions on how to install the Streamlit onto my computer.
Gotcha.
So
think,
anybody want to stick around so I can share my screen so we can get that done and over with, and then once that's all set up, I can just go practice everything on my own.
Yeah, I think and I don't want to answer for anyone, but that could be a possibility.
Yeah, I can stay around.
You're just who I was thinking of.
Yeah.
Any other questions?
Unrelated question, but I have a question for Jesse. Have you posted the link for how to connect data from Box directly to